Good morning everyone. Hope you guys are doing fine. This is AP Mishra, Senior Faculty of Physics from Chaitanya Gosala. As we have entered in the final phase of our NEET preparation, so today we are going to solve few important questions based on the mechanics of solid topic. So without wasting a time, let's quickly move to the question. So the first question which we have to solve here is a structural steel rod having a radius 10 mm and a length of 1 meter. We are applying an external force of 100 kilonewton on that rod. To do what? To elongate that rod. So you can see in this figure that we have a steel rod, and on that steel rod we have applied an external force on its cross section. Okay, and because of the application of this external force, the length of that rod has increased. So there will be an elongation in the rod. So now you can see what is the amount of elongation we have, that we have taken delta L. Okay, that delta L is the change in the length of this rod we have as compared to its initial length. Okay, so in this particular question they are asking us to calculate the stress value, the stress which is generated in the rod due to or during the elongation, and what will be the amount of elongation we have, which means delta L, and how much strain is there in the rod. And to calculate that, they have also provided us the value of Young's modulus of structural steel, and the value is 2 into 10 to the power 11 Newton per meter square. So quickly we can solve this. So first we are going to calculate here stress. We know the stress, how we can calculate it, will be a internal resisting force divided by area, and this internal resisting force we take equal to the external applied force. So that value will be equals to what? 100 kilonewton, which can be written as 100 into 10 to the power 3 divided by area. And since this force is acting on the cross section of this rod, so we can calculate that area how? Pi r square, where r is the radius of that cross section, which is given as 10 mm. So we can substitute that value also. So 100 into 10 to the power 3, this whole divided with pi into r square. R value is 10 mm, which can be written as 10 into 10 to the power minus 3 whole square. Okay. So if we further solve this, so final answer we are going to get is 3.18 into 10 to the power 8 Newton per meter square. Newton per meter square. That will be the value of stress we have got in this particular question. Now the second thing which they are asking us to calculate is elongation. So how we can calculate that elongation part? So elongation delta L we have to calculate. How we can calculate that delta L? So we know one relation. That relation is that Young's modulus of elasticity is equals to what? It will be equals to stress divided by strain. Stress divided by strain. Okay. So from there we can calculate first strain value. That is also we have to calculate. So strain will be equals to what? Stress divided by Young's modulus. So if we substitute stress, already we have calculated, and Young's modulus of elasticity they have already provided in the question. So quickly substitute that value here. So stress value we have is 3.18 into 10 to the power 8. This whole divided with Young's modulus, which is 2 into 10 to the power 11. If we solve this, the final answer of strain we are getting is what? That strain will comes out to be 1.59 into 10 to the power minus 3. And since this has to be calculated in the third part, so now only we have got that answer. So that is also one of our answer. And now finally we can calculate delta L, because strain is what we have. Strain basically is equals to what? Delta L by L. Okay, and we can calculate now delta L value, which will be equals to strain into its length. And what is the length of, what is the strain value we have? 1.59 into 10 to the power minus 3 meter into that length. What is the length they have given in the question? The length given to us is 1 meter. That length is given 1 meter. So we can write here 1 meter, which will give you the final answer again 1.59 into 10 to the power minus 3 meter, which can also be written as 1.59 mm. Okay. So this is what we have, the solution of this first question. Hope you guys have understood this particular problem, how we have calculated the stress value, how we have calculated the strain, and how we have calculated the elongation in that rod. Okay. So let's move to the next question. What mass must be suspended from a steel wire which is having a length 2 meter and 1 mm diameter, 1 mm diameter, and this wire is being stretched. This wire is stretched how much? 1 mm. It is stretched 1 mm, and they have given us Young's modulus of elasticity. So Young's modulus is given 2 into 10 to the power 11 Newton per meter square, and the acceleration due to gravity is given to us 9.81 meter per second square. What they are asking us to calculate? They are asking us to calculate the mass which we have to hang with that steel wire, okay, which will be responsible for its stretch. So we know here that, let's say this is the steel wire we have, and we are going to suspend a mass m, because of which there will be a weight in downward direction, and that weight is responsible for the generation of tension. That weight is responsible for the generation of tension, which will generate stress in this steel wire. The length of the steel wire is given 2 meter. Okay. Diameter we have is, diameter of the cross section is given to us 1 mm, which can be written as 1 into 10 to the power minus 3 meter. And they have also given the stretch, which can be taken as delta L, and that delta L value is 1 mm, which will be 1 into 10 to the power minus 3 meter again. Okay. So now we have to calculate that mass. How we can calculate that mass? Basically here you can say this here we have a equilibrium situation. Okay. So because of that equilibrium, the tension we can directly write equal to what? Mg. Okay. And we know that the Young's modulus of elasticity is equals to what? It is stress upon strain. It will be stress upon strain. So we can use that. So from there, if I write, so Y is equals to what? It is T divided by cross-sectional area into the length of wire divided by delta L. This we can write. And what we have to calculate? We have to calculate this M. So we will write here the values. So this will be what? Mg divided by pi d square by 4. That will be the area of cross section, which will be multiplied with the length. The length is given 2 meter divided by delta L, stretch, which is 1 into 10 to the power minus 3 meter we have. So after that we will try to calculate the value of M. Y value is given to us, so we can substitute that. So 2 into 10 to the power 11 will be the Young's modulus of elasticity. That will be equals to M into G. G value is given 9.81. This whole we are going to divide with pi into D value is 1 into 10 to the power minus 3 whole square. This will be multiplied with that 4 which we have here. This 4 will be shifted where? It will be shifted to numerator. So we are going to shift it in numerator. Then we will get finally here, and you can say that we also have here 2 divided by 1 into 10 to the power minus 3. Okay. So after solving this for the calculation of mass, finally the answer which we are going to get is approximately comes to be 8 kilogram. So the final answer after solving this, we will get what? We will get 8 kg. So this will be the answer we will get for this particular problem. I hope you have understood how we have used the concept of stress and strain to calculate that mass which we have hanged, okay, or which is responsible for the stretch in this steel wire. So let's move to the next question. So the next question which we have to solve in this particular question, they have given that there is a body which is having a mass m, and in air we are going to hang this with this string. Okay, so at this particular situation, in this particular situation, this will have a weight mg in downward direction. Okay, and because of that there will be a tension in upward direction. Okay, what basically they are asking us to calculate, they are asking us to calculate the elongation. They are asking us to calculate the elongation in the string when it is kept where, when it is submerged in a non-viscous liquid. Non-viscous liquid. So initially it was in air, and when we have submerged it in a non-viscous liquid, then what will be the elongation this string will have through which it is hanged? They have given us the elongation when it is hanged in air. What is the elongation they have given in air? The elongation is given E. They have given the elongation E. So we know that here this weight of this block will be balanced by this tension. Okay, so here if we try to calculate the elongation, so we have already know that the elongation basically is represented by delta L. So we are taking this delta L, which is given equal to E, and that we can write equal to what? This can be written equal to stress divided by Young's modulus of elasticity into the length of that wire. So that will be the relation we have to use, and stress can be further written as what? The tension divided by area. So tension I am going to write here mg directly. So mg divided by area into L by y. Okay. So from there you can see that in this particular situation, initial situation and this situation when this block is submerged in a liquid, in both the situation the mass of the body is going to remain what? Same. Okay, there is no change in the mass, and length of the wire is also going to remain same, initial length. Here when we say L is the initial length of the wire, and A is what we have, it is the area of cross section of this wire. So that is also not going to change. Okay, and Young's modulus of elasticity, that is also not going to change. The variation we will get where? The variation will be there in its G value. The variation will be there in its G value. Okay, so in this case you can see this will be the value we have. So this we have when? In air. So this is the elongation relation we have in air. Okay, now if we try to write the same elongation relation when that block is submerged in water, so or not water, non-viscous liquid, then in that case you can see that we have downward. Now in this case the weight will be what? This will be apparent weight, and that apparent weight value will be what? Mg 1 minus density of liquid, which is given as dl. They have given us the density of liquid, okay, dl, and density of solid is given to us dv. So we will get here dl by dv. Okay, so that will be the value of the apparent weight we have, and now you can see we have again the tension that we can take as T dash. So now the elongation equation we have in liquid, the elongation equation which will be delta L dash, you can say that I will take as E dash. So this E dash value we have is what? It will be in place of mg. In place of mg, now we will write what? We are going to write mg into 1 minus dl by dv, which will be divided with area of cross section into L by y. Okay, so this we can take as what? This we can take as equation 1, and this you can take as equation 2. So when we are going to divide these two equations, then what will be the final answer we are getting? So if we divide the second equation with first equation, then E dash value will comes out to be what? Because you can see that all the values will going to cancel. This mg, L, A and Y, these four quantity will get cancelled when we are going to divide these two equations. The only quantity which is not going to cancel, it will be 1 minus dl by dv. So what we will get? E dash by E will be equal to what? 1 minus dl by dv, dl by dv, which finally gives us the answer or new elongation value equals to initial elongation E into 1 minus dl by dv. So that will be the elongation. That will be the elongation we have. I hope you guys have understood this particular problem, how we have reached to the solution. Okay, so this will be the answer we have. So let's move to the next question now. A tangential force which is having a value 2100 Newton is applied on the surface area 3 into 10 to the power minus 6 meter square, which is 0.1 meter from a fixed face. The force produces a shift of 7 mm of upper surface with respect to bottom, then the modulus of rigidity of the material. So basically in this particular situation, what they have given, we can understand it by the diagram. So here you can see that there is a object we have, and that object has at the bottom you can say this is fixed. The bottom of this object is fixed. Okay, and from the top we are applying a tangential force. Okay, and because of the application of this tangential force, what will happen? The upper part is going to move forward. Okay, so there will be a movement we have of this upper part, and because of that you can see that there will be a stretch, and that stretch we are going to get, or you can say there will be a movement of the upper part, and that how much it has moved, that we are taking delta x. The length of this we have taken is what? L, and the value of this L is given to us. This L we have is what? The length value they have given is 0.1 meter. Okay, and how much shift is there? Shift is delta x. That delta x value we have is what? It is given to us 7 mm. The shift value is given to us 7 mm with respect to bottom, and the force which we have is what? It is 2100 Newton. So we have to calculate the modulus of rigidity. How we can calculate? So modulus of rigidity formula we have is what? Modulus of rigidity is equals to what? It will be equals to the shear strain, shear stress divided by shear strain. Shear stress divided by shear strain. What is the value of shear? How we can calculate shear stress? So shear stress value we have is what? It will be force per unit area. Which force? Tangential force. Okay, and they have given us the tangential force value. So we can calculate that here. So that modulus we have is what? It will be equals to the shear stress value 2100. That force we have is what? 2100 divided by the area. What is the area they have given? The area of this upper surface on which the force is acting. That area is given 3 into 10 to the power minus 6 meter square. Okay, this whole has to be divided with the shear strain. How we can calculate the shear strain? So that shear strain you can calculate by delta x by L. This L, and how much, whatever the shift is there, that has to be divided with L. Shear stress, how we have calculated, it was the tangential force per unit area. So now we can substitute that delta x value, which will be 7 mm. 7 mm is 10 to the power minus 3. This whole divided with L. L value we have is 0.1. L value we have is 0.1. And if we solve this particular value, the final answer we are going to get is 1 into 10 to the power 10 Newton per meter square. So you can see we have 4 options here. So out of this 4 option, where we have that option which we have calculated here. So this option is given in C option. So C option is a correct option for this particular problem. So I hope you have understood how we have calculated the modulus of rigidity. So the next question we have is two blocks of masses 1 kg, 2 kg are connected by metal wire going over pulley smoothly, and that pulley is taken as what? Smooth pulley. Okay, there is no friction present in the pulley. The breaking stress of the metal is, so they have given a breaking stress value which is 40 divided by 3 pi into 10 to the power 6 Newton per meter square. Newton per meter square. Okay. What should be the minimum radius of wire used if it should not break? Okay. So basically what they are asking us to calculate, they are asking us to calculate the radius of the cross section of wire so that it will not break. It means we have to calculate the maximum radius which can be possible for that wire. Okay, by using this breaking stress value. So what is given in this particular question? So you can see that they have given a pulley, and through that pulley there is a string, and we have connected a two blocks. One block is having a mass 1 kg, second is having a mass 2 kg. Okay, so now in this particular situation, first we have to calculate what will be the tension we have in the wire. So we know that the tension in the wire we can calculate. We have a direct relation to calculate that. You might remember this relation, that 2 m1 m2 divided by m1 plus m2 into g. This is the relation we use to calculate the tension in the wire. So what will be the value we are getting here? 2 into m1 value is 1, m2 we can take 2 divided by 1 plus 2 into g. G value we can take here 10, as they have given g value as 10. So we will use the same value 10. So what will be the value we are getting? The tension we are getting is what? It will be 40 by 3. What we are getting? 2 into 2, 4, 4 into 10, 40 divided by 1 plus 2, which is coming out to be 3. So 40 by 3 Newton, that will be the tension we are getting. Once we got the tension, now we can calculate that radius. How we can calculate? We know that stress is equals to what? It is equals to force per unit area, and that force is tension. So tension upon area. Okay. And area value we have is what? It is, how we can calculate area? This will be pi r square. Pi r square. So now if we try to calculate this r, so for that you can see we have to write T divided by pi into stress. This whole value we have to take under root. Now we will substitute the value. So we are getting what? Under root of this we have here 40 divided by 3, that is the tension, divided by pi into what is the breaking stress we have? That breaking stress value is given to us 40 divided by 3 pi into 10 to the power 6. Okay. Now you can see that this pi is going to get cancelled here, and we also cancel this 40 and 3. Okay. So what is left with us? We have 1 divided by 10 to the power 6, and that 10 to the power 6 will be shifted in numerator and it will become 10 to the power minus 6. And since it is under root, so the final value we will get is what? 10 to the power minus 3 meter. 10 to the power minus 3 meter, and 10 to the power minus 3 can be taken as what? 1 mm. R value we are getting is what? 1 mm. So this is the answer we have. So the radius value we are getting is what? 1 mm. So you can see that out of these 4 options, what is the correct option we have? The B option is the correct option. B option we have is correct option. Okay. So let's move to the next question now. Now you can see that in this particular question, very simple question it is. Determine the pressure required to reduce the given volume of water by 1%. How much? By 1%. Bulk modulus of water is given 2 into 10 to the power 9 Newton per meter square. Newton per meter square. Okay. So now in this particular situation, they are asking us to calculate what? The pressure which we have to apply in order to reduce the volume by how much? 1%. By how much? 1%. So let's calculate that. We know that bulk modulus relation is what? Bulk modulus is equals to minus of delta P. Delta P is the pressure which we are applying in order to decrease the volume, divided by volumetric strain delta V by V. Now in this question they have already given us the volumetric strain which is delta V by V, and that is given minus 1 by 100, because they have given that there is a decrease in the volume by 1%. Okay, so that can be taken as a volumetric strain, and since it is reduced, so we have to keep a negative sign also along with that. So the delta V by V value we are getting is what? Minus 1 by 100. Okay, and bulk modulus is already given, so delta P value we have to calculate. So delta V value we are getting is what? It will be minus B into delta V by V, which will be minus, bulk modulus is 2 into 10 to the power 9 into delta V by V, which is minus 1 by 100. Minus 1 by 100. So this minus and minus will become what? Positive. Okay. And finally the answer we are getting is what? What will be the delta P value we are getting? It will comes out to be what? 2 into 10 to the power 7. 2 into 10 to the power 7, because here you can say that this 9 is going to be cancelled with, we will get what? Now the 10 to the power 7 only remaining, because this 100 will cancel the 2 zeros here. Okay. So we are getting finally this delta P value 2 into 10 to the power 7 Newton per meter square. So that will be the final answer we have for this particular question. So I hope you have understood this question. Next, let's move to the next question now. Okay. So the next question which we have, which is again a very simple but yet very important. The modulus of elasticity is dimensionally equivalent to which quantity? So they have given us the 4 quantities here. They have given stress, they have given surface tension, they have given strain, and they have also given coefficient of viscosity. So dimensionally, which quantity will have equivalence with modulus of elasticity? Okay. So modulus of elasticity dimensional formula is what? So that formula, the unit of modulus of elasticity we have is what? It will be Newton per meter square. Okay. And we know that dimensionally Newton, that is force. So what will be the dimension formula we have? It is ml t minus 2 divided by this meter square will become what? L square. So from there, if you write the dimensional formula we are getting is what? This dimensional formula will comes out to be what? It will comes out to be m L minus 1 t minus 2. So that will be the dimensional formula we have for modulus of elasticity. And we know that stress has the same unit as of the modulus of elasticity. So obviously this will have the same dimension as of the modulus of elasticity, which means its dimension is also ml minus 1 t minus 2 we have. Okay. Whereas surface tension is what? It is force per unit length. Force per unit length. So its dimensional formula will comes out to be what? It will be ml t minus 2 divided by L, which will give you finally the dimensional formula mt minus 2. That will be the dimensional formula we have for this surface tension. Strain is a dimensionless quantity. Okay, it is unitless as well as dimensionless. Coefficient of viscosity, its dimensional formula we have is ml minus 1 t minus 1. Okay, how we can calculate? So you can use this relation, which is F is equals to 6 pi coefficient of viscosity into R into terminal velocity. So from there you can calculate the coefficient of viscosity dimensional formula. Okay, so out of these 4 quantities, the only quantity which is having a same dimension as a modulus of elasticity, that is A option, which is stress. Okay, hope you have understood that. Very simple question. Let's move ahead. Okay, so the next question we have, the bulk modulus of perfectly rigid body is. What will be the bulk modulus we have for the perfectly rigid body? Okay, this is a very good conceptual question. So here you can say, when we say rigid body, what is the meaning of the rigid body? So when we are saying rigid body, there is no deformation, the body which cannot be deformed. So non-deformable body, non-deformable body, non-deformable body. So this is what we have, non-deformable body. So now when non-deformable body is there, so bulk modulus is what we have, it is minus delta P divided by delta V by V, where delta V represents what? It is a deformation, which is a change in the volume, and since it is a rigid body, there is no change in the volume. So we can take that delta V value, we have to take what? Delta V here we have to take for the rigid body 0, which means if you substitute that 0, so bulk modulus value we are going to get is what? Infinity. So what is the value of bulk modulus we have for the rigid body? It will be infinity. So correct option is C option. Okay, I hope you have understood that. Okay, so let's move ahead. Okay, now the next question, which is again a very important conceptual question, the stress strain curve. Okay, so you can see this stress strain, this is what we have. This is a curve between stress and strain. Basically what we are doing, we are taking a material and we are applying an external load on that, which means external force we are applying on this material in order to elongate it. Okay, and that force we are increasing gradually. Slowly that force value is getting increased, and when that value of force is gradually increased, then what will be the behavior that material is showing? Okay, that is being plotted in the form of its stress strain curve. Okay, what they are asking us to find out in this graph, this is the graph we have. They are asking, in this graph we have to find the region where Hooke's law is valid. Hooke's law is valid, and ultimate strength point. Ultimate strength is the maximum possible stress value. Okay, and then fracture point. Fracture point is a point where the material is finally going to break, because when we keep on increasing the force, there will be one point when the material is going to break. So that point is a fracture point. So here in this particular graph, what are the situations or what are the regions we have? So you can say that from the starting, from O point, from the starting up to this A point, this particular region is the region where stress is proportional to strain, which is the condition of Hooke's law. So this OA region is the region of Hooke's law validity. Okay, beyond this point, the Hooke's law is not valid. Beyond A point, there is no validity of Hooke's law. Okay, so that is the Hooke's law point or Hooke's law validity region. And this D point, you can see that this D point is giving you what? The maximum value of stress. You can say this is the maximum stress value point. Max stress we have at D point. Okay, and finally the material is going to break at this E point. So this E point is also called fracture point. Fracture point. Okay, so what will be the option? Option should be OA, D and E. Now, if we see the option, in all these options, which one is the correct option? So you can say the C option will be the correct option, where OA, D and E is given as answer. Okay, I hope you have understood this question. Let's move to the next question. Okay, again, so now you can see in this particular question, the stress versus strain curve. So you can see that this graph is given, and this graph is a graph between stress and strain. Okay, for wires of two material A and B. So we have two material A and material B. Material A and material B. Okay, if YA is the Young's modulus of material A and YB is the Young's modulus of material B, they are asking us to calculate what? They are asking us to find out the relation between those Young's modulus of elasticities of two material. So how we can calculate? Basically, Young's modulus according to Hooke's law is equals to what? Stress upon strain. And in this particular curve, when we see, so the slope of this graph, slope of these graphs are giving us what? They are giving us the value of Young's modulus of elasticity. Okay, so basically that we can take equal to what? Slope of stress strain graph. Stress strain graph. Okay, which will be equals to what? We know that slope value is equals to what? It is equals to tan theta. Theta is what we have. It is the angle that curve is making with respect to the positive x-axis. So we can write here y is equals to tan theta. Okay, so based on that we can write YA value. YA value will be what? You can see this A. So this straight line curve is making what? It is making an angle 60 degree with respect to positive x-axis. So we can write here YA is equals to what? Tan 60 degree. And tan 60 degree value we have is what? It is √3. It is equals to √3. And YB value we have is what? YB value is equals to tan 30 degree, because here the angle we have is what? 30 degree. The curve B is making an angle 30 degree with respect to strain. So this will be equals to what? This will be equals to 1 by root 3. This will be equals to 1 by root 3. Okay. So now we can do what? We can divide these two equations. If we take this as equation 1, this we can take equation 2, and then we can divide this first and second equation. So by dividing this first and second equation, you are going to get what? We are going to get that YA divided by YB will be equals to what? It is going to come equal to root 3 divided by 1 by root 3, which will finally gives you the value 3. Okay. And from there we are getting what? We are getting that YA value we will get is what? It is 3 times of YB. It is 3 times of YB. So you can see that which option is giving us this relation. So YA is equals to 3 times of YB is given in D option. So that D option is the correct option for this particular problem. I hope you have understood that. So let's move to the next question now. Okay, let's solve this particular question. In this question, they have given to us a mild steel wire of length 2L. The length of this wire is given what? 2L. Basically, you can see that the wire, this is what we have, the mild steel wire, which they have given to us. Okay, that this will be the wire which is having a length 2L. Okay, and cross-sectional area of this wire is given what? It is given A. And this wire is stretched. Why it is stretched? Because we are going to hang a mass M, because of which the wire is going to stretch, it will move down, and that will put, or that is going to stretch the wire little bit. Okay, so this is, you can say how much it is going to move down. It is moving X. It is moving X downward because of this hanging mass, and because of that there will be a stretch in the wire. Okay, what they are asking us to calculate, basically they are asking us to calculate the strain in the wire. What is the strain we have in the wire? Okay, so it means that strain value, that is delta L by L value, they are asking us to calculate. How we can calculate that? So if we take this particular diagram, so in this case you can say that half length up to this total length we have is what? It is 2L. So up to half the length is what we have, it is L. Up to half the length is L, and this particular length, after this wire has moved slightly down because of that hanging mass, what will be the length we have of this portion? It will be, by using the Pythagoras theorem, because this is what we have, a right angle triangle, so it will comes out to be L square plus X square under root. So that will be the length we have. So same way here also you can see that length will comes out to be what? Under root L square plus X square, as this length also is what we have, L. Okay, so initial length, what is the initial length of the wire we had? So initial length we had is what? L initial was what? Initial length of the wire we had is what? Total length, it was 2L. Finally, what is the length we have? Final length value we have is what? It will be equals to 2 times of under root L square plus X square. And this we can do what? We can also take this L square outside. If we take this L square outside from the root, then we can write it in this way: 2L under root 1 plus X square by L square. Can we write or not? Yes, we can write. So now what we will do, we will try to first calculate the change. What is the change we have got in this length? Okay, in the length of this wire. So that delta L will be what? It is the final length minus initial length. So when we substitute that value, so final length value will be what? It will be 2L under root 1 plus X square by L square minus initial length value we have is what? It will be 2L. So now we can do what? We are going to take the 2L value common. If we take that 2L value common, then we will get here under root. That under root can be written as what? We can take that power as 1 by 2. We can take that power 1 by 2. So let's write it in this way: 1 plus X square by L square power 1 by 2 minus 1. Okay, so that will be the value we have. That 2L we are going to shift other side, so which means we are going to get delta L by L. Okay, delta L by 2L. Okay, and that value is what? That value is strain. Okay, because total length, whatever the stretch or change in the length we have, divided by the total length, that will be the strain we have. It will be equals to what? Now it will be equals to this 1 plus x square by L square power 1 by 2 minus 1. Now here we are going to use a binomial expansion. Why we are using? Because the this wire is not going to move very much down. Okay, that value will be very small, or that movement of that wire will be very small. Okay, so that x value is very small when we compare it with the size of this wire. Okay, so that since this x value is very small, so this ratio will be very small as compared to 1. Okay, so we can say what here? You can say since x square by L square is very much less than 1. So we can use here binomial expansion. Okay, so what will be the final answer we are going to get? Final answer for the strain we are getting, strain will comes out to be what? 1 plus that when we apply the binomial expansion here, so whatever power we have here 1 by 2, that we will multiply with x square divided by L square. So this will comes out to be what? 1 by 2 into x square by L square. Okay, and this minus 1. So now you can see that this one will get subtracted with this one and 1 will get cancelled. So finally the answer which is left with us, that will be x square by 2 L square. So that will be the final answer we have. Okay, that will be the final answer for the strain value we have. So if we check the options here, which option is giving you the right answer? So that is A, x square by 2L square. That will be the strain we have in this wire because of this hanging mass. Okay, I hope you guys have understood this particular problem. So let's move to the next problem. So now we are going to solve few questions based on the earlier examination. So the first question which we have here is, if S is a stress, they have given S as a stress and Y is a Young's modulus of elasticity, the energy stored in the wire per unit volume. Okay, so energy stored, first of all, energy stored per unit volume. U is representing energy and V is representing what? Volume. Okay, so energy per unit volume, that formula is equals to what? It is half stress into strain. This is the formula we have. They are asking us to calculate what? They are asking us to calculate this energy per unit volume, but they have not given the strain value. Instead, they have given Young's modulus of elasticity. So nothing. We will do what? We will simply substitute this strain in the form of stress and Young's modulus, because we know that Young's modulus is equals to stress upon strain. So we will write here 1 by 2 stress into stress upon Young's modulus of elasticity. So finally the answer we are getting is what? U by V. We know that stress is given as what? Stress is given as S. So we are going to, and stress we are having 2 times. So stress square we have. So we can write here S square divided by 2 into Young's modulus is represented by what? It is given as Y. So we can take it as what? S square by Y. So U by V is equals to what? It is equals to S square by 2Y. So that will be the final answer we have. If we see the options, so out among these options, the final answer we are getting by this C option. Okay, so I hope you have understood this question also. Let's move to the next question. For a constant hydraulic stress on an object, the fractional change in the object's volume is delta V by V. Okay, so they are saying that we are applying a constant hydraulic stress. We are applying constant hydraulic stress. Okay, because of which there will be a change in, or we have a fractional change in the volume, which is delta V by V. Bulk modulus is given by V. They are asking us to find out what is the relation we can write between the bulk modulus and fractional change in volume. So basically you can say that bulk modulus is equals to what? Minus delta P by delta V by V. Okay, and here since they are saying that we are applying a constant hydraulic stress, which means that delta P value we can take what? We can take this value as constant. This value can be taken as constant, and we can, if we cross multiply this, so we are getting what? Delta V by V. We can write what? We can write minus delta P by B. If we take this delta P constant, then proportionality can be written as what? we can write delta V by V. We can write delta V by V proportional to 1 by B. Delta V by V is proportional to 1 by P. I hope you have understood that. Okay. So if we see all the options, the correct option is given by C option. Okay. So that is a correct option we have. Okay. So let's move to the next question. Here they have given 4 wires. The following 4 wires are made of same material. So we have a 4 wires and all the 4 wires are made up of same material. When they are made up of same material, it means their Young's modulus of elasticity will be taken constant. Which of these will have the largest extension when the same tension is applied? So again you can see that to each wire we are applying a same tension. Okay. So if we take this wire, so this wire is having what? The wire is having a same tension, or tension is there in the wire, and these wires, not only this, all the wires which we have 4 wires, all 4 wires are going to have a same tension. Okay. Why there will be a tension? Because when we try to stretch it, that tension will oppose that stretch. Okay. Now, what they are asking us to find out, they are asking us to find out that among these 4 wires, which one is going to have the largest extension? Which one is going to have largest extension? So how we can calculate that? So here you can see that if we try to calculate, if we use that delta L relation, what is delta L? How we can calculate that delta L? So we have already understood that delta L will be calculated. How? It will be the tension divided by area, which is stress, and we can multiply with the length divided by the Young's modulus of elasticity. Now in this particular situation, you can see that area can be written as what? They have given for all the 4 wires, they have given diameter. So how we can write the area of cross section in terms of diameter? This will comes out to be what? T divided by pi d square by 4 into L by y. So delta L value we are getting is what? So in this case you can say tension divided by pi, this 4 and y. These values are what? These are common in all the wires. Okay, they are same for all the wires. The only thing which is not same, that is the ratio of L by d square, where d is the diameter. So we have to check for each wire the ratio L by d square, whichever is giving us the highest value of L by d square, that will have the highest delta L value. So we can quickly check the value of L by d square. So if we take for the first wire, for this wire, you can see that L we have is what? L by d square, that ratio we calculate. So this will comes out to be what? 100 centimeter. So 100 into 10 to the power minus 2 divided with d square, we have 1 mm. 1 mm can be written as 1 into 10 to the power minus 3, and we can take square here. So what will be the final value we are getting? So final value we are getting is what? You can say this 100 is going to cancel that minus 2, 10 to the power minus 2. So we will get here 10 to the power 1 into 10 to the power 6. 1 into 10 to the power 6. This is for the first wire we are getting. Second wire dimensions are given, which is 50 centimeter and 0.5 mm. If we calculate for that, the value we are getting L by d square value we are getting is what? For second wire it will be 50 centimeter. So 50 into 10 to the power minus 2 divided by 0.5 mm. 0.5 mm means what? 1 by 2 into 10 to the power minus 3 whole square, which will give us finally that 1 by 2 whole square will become what? 1 by 4. That 4 we can multiply with 50, which will give you what? 200. Okay. So 200. So finally here we are getting what? 2 into 10 to the power 6. We are getting here 2 into 10 to the power 6, which will be greater than the first one. Now for the third one, if we try to calculate. So for the third, if we try to calculate that L by d square ratio, so this will comes out to be what? For the third, they have given 300 centimeter as a length. So 300 into 10 to the power minus 2 divided by the diameter. That diameter is what? 3 into 10 to the power minus 3 whole square. So this will comes out to be what? We are getting here the value 300 divided by 9 into 10 to the power 8. Okay, and 2 zeros we can cancel. So finally we are getting what? This 3 and 9 also we can cancel. So we are getting 1 by 3 into 10 to the power 6. Okay, so again you can say 1.1 by 3 into 10 to the power 6 is 0.33 into 10 to the power 6, which will be lesser than 2 as well as it is lesser than first option also. So now the fourth one we can take. Here. The fourth option which we will have is what? It is 200 centimeter and diameter is given 2 mm. So if we check for that also, so that 200 L value we have is what? 200. That 200 into 10 to the power minus 2, this divided by, so this 0 and 10 to the power minus 2 directly we can cancel. This divided by 2 mm, which is 2 into 10 to the power minus 3 whole square, and this will become what? 2 by 4. 2 by 4 is again 1 by 2. So we are getting what? 1 by 2 into 10 to the power 6. So you can say among all these 4 wires, the wire which is having the highest ratio is what? It is the second one, which means that B option is the correct option. So this wire is going to give us what? It is going to give us the highest value of delta L. Highest value of delta L. Okay, I hope you guys have understood that question. Okay, so the next question we have here is copper of fixed volume is drawn into a wire of length L when this wire is subjected to constant force. When it is subjected to a constant force, the extension produced in the wire is delta L. What is the extension produced? Delta L. Which of the following is straight line? Which of the following is straight line? So here you can see that they are saying that copper is having a fixed volume. The volume of that copper material is what? Fixed. We are going to use this to make a wire. So every time, all the time, whatever the length of that wire we have, that volume is going to remain same. Okay, so volume is taken as given as what? It is given constant. Volume is given constant. And what they are asking us to find out the ratio of that delta L. So with respect to these values, we will try to find out what will be the appropriate relation here. So you can see that delta L we know is equals to what? It is equals to stress, which can be written as force upon area, into the length of that wire, that we can take L, divided by the Young's modulus. So this will be the relation we have for the calculation of delta L. If I multiply this and divide with L, so you can see that A is what we have. This A is the area of cross section, and when we multiply it with the length of the wire, then it will give you what? This will give you what? This multiplication will give us what? Volume. And we know that volume is constant. Okay, and you can see that now that delta L becomes what? It becomes F divided by volume into Young's modulus into L square, because L into L square. And these values are what? These are constant. These are constant values. So what we are getting? We are getting delta L proportional to L square. Delta L proportional to L square, which means this is the appropriate relation, and the graph of this will be what? It is straight line, because it is following what? If you see this equation, it is following this equation, y is equals to mx. Okay, so that will give you the straight line. And out of this 4 option, which one is giving you the correct answer? This B option is giving us the correct answer. Okay, so I hope you have understood this question. Okay, so let's move to the next question. So 2 wires are made in this particular question, but they have given 2 wires are made of same material. 2 wires are made of same material and have the same volume. Again, they have given same material is there and same volume is there. Same material means their Young's modulus is same and volume is going to be equal. However, wire 1 has a cross-sectional area A and wire 2 has a cross-sectional area 3A. So we know the volume is constant. So when volume is constant, then in that particular situation we can do what? We can take area of first and length of first equals to what? Area of second into length of second. Okay, from there we can try to establish a relation between the length. Area relation is given to us. So A1 value we have is what? A1 will comes out to be what? They have given this as A, and L1 we can take L1 only. A2 we have is what? 3A, L2. So A and A we can cancel both sides. So from there you can say we are getting L1 value is equals to what? L1 value we are getting 3 times of L2. So this is the length relation we have. Area relation they had given, length we have calculated. Now further if we see this question, if the length of wire 1 is increased by delta x amount, so there is an extension we have or stretch we have, that is delta x. On applying a force F, how much force is needed to stretch second wire by the same amount? So again you can say that here they are saying what? That the value of delta x is same. Value of delta x is same. And we know that delta x we have is what? How we can calculate the stretch value or elongation? That will be equals to what? It will be force upon area into length divided by what? Young's modulus. Okay. And this delta x is same for both the wires. So we are going to equate. So delta x for first is equals to what? Delta x for second. Delta x for second, which will be equals to what? So now if we substitute these values, so we can write here what? It will be what? It will be F1 divided by A1 into L1 divided by Y1, which will be equals to what? F2 divided by A2 into L2 divided by Y2. A2 divided by, L2 divided by Y2. Now here you can say in this particular question they have given the same material, so it means that Y1 and Y2 both will be same. So we can cancel it. Okay. And they are saying L1 and L2 relation we have calculated, so we can substitute that. So here you can say that F2 we are going to shift here, so we are getting what? F1, or we have to calculate F2. F1 we know, so let's substitute that F1 this side. So we are getting F2 by F1, which will be equals to what? F2 divided by F1, and L2 we are going to shift, so it will be L1 by L2 into this will be A2 by A1. A2 by A1 we have, and we can substitute these values. We have here L1 value 3 times of L2. A2 value we have is what? It is given 3A. So we can take 3A divided by A. A1 value is A. So L2 we can cancel, A we can cancel, 3 into 3 is what? 9. Okay. So we are getting here F2 value equals to what? 9 times of F1, and F1 is given what? F. So final answer we have is what? In order to have the same stretch, how much force we have to apply? We have to apply 9 times of the force which was applied on the wire 1. Okay. So that will be the answer we have. If we check these options, what is the correct option? C is the correct option. I hope you have understood that. Okay. So the next question we have is what? When a block of mass M is suspended by a long wire. When a block of mass is suspended by a long wire of length L, the length of the wire becomes what? It becomes L plus small l. L plus small l. That small l basically is what? This small l value we have is what? It is delta L. Okay. So here you can write that stretch we have or elongation we have is what? It is given as small l. Okay. The elastic potential energy stored in the extended wire is. What will be the elastic potential energy? So elastic potential energy formula we have is what? Elastic potential energy formula is equals to what? It is 1 by 2. Since they have given us here the value, so we can write here what? It can be written as stress into strain into volume. So this will be the relation we have to use in order to calculate the elastic potential energy. Stress value will be what? It is force per unit area. And what will be the force we have? You can say there is a block which is suspended with a long wire. So the tension will generate a stress which will be equals to what? Which will be equals to mg. Okay. So we can write here stress value mg divided by area. Mg divided by area into strain. What is strain? It will be delta L by L. And volume is what? It is A into L. Area of cross section into the length of that wire. into the length of that wire. So L we can cancel and area also we can cancel, and delta L we know is L. So what will be the answer we are getting? The potential energy, elastic potential energy we are getting is what? It will comes out to be what? It is 1 by 2 mg into this delta L value, we can substitute this L. This will be the elastic potential energy, half mgl. So you can see, if we see the options, the correct option we have is what? C option. Half mgl is the final answer we have. Okay. Thank you boys. Hope you liked the session. If you liked the session, please share it with your friends.